Good day, everyone. Today we are going to discuss polynomial graphs. In the objective, we're going to solve equations and using graphs to check our work. Solve equations using the quadratic formula. Analyze the graphs if we have time, which that's for the next video. And tell stories about the graph. That's also going to be next video. Announcements. Y'all, do not forget, those supplies I have in the classroom are limited. I do not have an unlimited amount. And remember, those supplies like pencils and calculators are for everyone. So when you finish using pencils and calculators, please return them to the proper place. Do not have pencils out on the desk. Please don't allow me to pick them up. Or it's going to be a situation where you yourself have to be responsible for your supplies. The school has been very nice to us by giving us the supplies. There are some districts where you, the student, have to have your supplies coming from your house. Alright, so please let's not take that for granted, alright? Yeah, homework turning percentages is too low. I need for you guys to start turning in those Kahoots. Those Kahoots are me personally creating them myself just for your pleasure. You asked me, Mr. Howard, please don't give us no workbooks to do for homework. Please don't give us worksheets. So I did my part. Please be with me and respect me by getting that homework done. Because, like it or not, folks, your incoming quiz is going to come from most likely the homework and stuff from the videos. Alright, so at the end of this week is when your quiz gonna happen. Or I'd probably be nice to say, you know what? It's Monday. So y'all, keep in mind, quiz is not gonna take the whole class period. It won't. Be aware of academic dishonesty, y'all. It could really seal your fate. After quiz, we're going to be looking at Math Nation materials, ACT materials. We will finally write in the math class. Unfortunately, that's something that we have to do class-wide. Homework will be included, will include more old material. And you're going to see more writing stuff in the Kahoots too, so be prepared. Don't forget, if you are absent, please take care of your business. I will always have work online for you to do. If I don't have it during the class period, most likely it's going to follow up in terms of homework. So please be about your business. If you have an excuse, make sure that I get a copy of it. Also, if you prefer paperwork over classwork, just see me. Just say, Miss Alec, I have the paper version of it. And I'll make it happen. Alright. Good job, 3A. You guys have made lots of improvements. 4A, you guys give the best performance. 7B, your compliance is good. 1A to 7B, you've been handling your business with me. I really like you guys a lot, so good job with that. Alright, be aware. Yeah, I know this math class is making you guys go bonkers, but please don't let Algebra 2 be the reason why you have to take math courses again. Please don't do that. Alright, math is about applying old concepts learned to new material. Mistakes allow thinking to happen. As I tell you guys countless times, you can get it wrong before you get it right. You know, when we're doing work together, you got classmates to work out with you. Don't come to me first. I'm the last person you want to see. And not only just that, because most likely we do go over it and we do take good notes. Alright, when you ask me, I'm not going to just give you a straight up answer. Hey, the answer is 5. No, 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 no. Because I want you to come up with the answer yourself. Because you'll be amazed with what you can do. Teacher's not going to do too much time on the board. Recall all previous class lessons. This is big because many of you guys coming in not paying attention to what was being taught to you. It's going to be concerned because I may just say, hey, I'm going to take your notes away from the quiz because those open nose quiz, that's me being nice. I don't owe you guys that, but I choose to be nice. But I will tell you this, if my homework percentage don't increase, you're going to lose those notes. All right. Review. Okay, let's answer these quick questions. What's the additive inverse of 5? Negative 5. What's the multiplicative inverse of 2? 1/2. What is the steps of factoring a trinomial with a leading coefficient with a leading exponent of 2 and a leading coefficient of 1? Find the factors. They give me the product of C and the sum of B, which you guys did a lot of. Another word for solution is 0 and roots. What is the exponential inverse of x squared? Square root of x. Can you have a negative integer in the square root? Nope. What is the answer of negative 36? Plus or minus 6i. Does the leading exponent tells you how many solutions you have? Not always. Not always. Just look back at stuff that we did previously with solving equations. Alright, let's solve equation by factoring. We did this particular problem in class. Alright, we know that 4x is your greatest common factor, and we know what's inside is going to be 2x plus 5. Now, in order for us to make an equation, we have to set the greatest common factor in the factor to equal 0. The equation to the left, divided by 4, you're going to get 0. 0 divided by 4 is always 0. And then the equation to the right is going to be negative 5/2. To be honest with you, I'm not going over this particular detail. I'm not going over this detail because by now you should know how to do that. Because we've been over it. I've been over it. If you're struggling with that, please watch previous videos. Because one thing that Howard is not going to do is to go over the same thing 1,000 times. He's not doing that. You got the videos, you got the resources. Look at your notes if you've forgotten. And your solution is negative 5/2 over 0. Now, today's lesson, as I've told you guys beforehand, is to put this in decimals and graph it. I'm going to show you how I get to that. And the reason why you're doing it like this, because when you take A-net, because A-net is a grade, and it's either going to put you in a good place or a bad place. Let's find out decimals. So speaking of which, go to decimals.com. And also I left out some key information that we're going to talk about. So once you get to decimals, I need for you to click there. When you click there, you get this beautiful site. Now, before you decide to go on and do all these other things, I need for you to slow down with me. All right? So this is where you're going to put your equations in. All right? Now, the graph details is going to be right there. You could change the color. You could make your graph thicker. You can make it skinnier. You could make it prettier if you want to. So you could do that right there. Also, the keyboard. Click on the keyboard to type in quadratics, exponentials, all of that stuff. We're going to zoom in and zoom out over here. And your settings for your graph is going to be right there. All right. So let's put back the equation that we did, the ax squared plus 20x. So type in 8 right here in the equation information. So type in your 8x, but make sure you pay attention to this arrow because this is telling you how to get to the keypad to type in your information. Especially when you're trying to do this on your phone, for sure. When you're trying to do this on your phone, you definitely need to do this on the keypad. Alright, so type in 8x. And then to do your exponent, type in this AB key right there that you see. Hit the AB key right there and type in 2. Now, the reason why I want you to do that because in the future throughout the year, you're going to be dealing with exponents of 10, 20, 100. It's going to go beyond just 2. Alright, after you type in 2, make sure you put a little space down. So you can type in plus. Well, before you do the plus, if you did, erase it for a second. Do you get a graph that looks like this? When you get yourself a graph like this, good job. Now let's finish it up. 8x squared plus 20x. When you put the equation like, or the function like that, you get something that looks like this. If you got that, good job. Now, you are looking for something in particular to check your work that we did before. So, zoom in for me, and you should see the graph better. When you zoom in, you should see what you need to see. What I'm looking for is your x-intercept. The x-intercept. The x-intercept. When is the graph crossing the x-axis? When? At what values? At negative 2.5. Right there. And when x equals 0. Right there. Negative 2.5. When we put it in the fraction form, you're going to get that negative 5 half. Now again, this is another way to check your answer. X-intercept is another word for 0, roots, solution. Intercept, X-intercept is another word for solution, 0, and root. X-intercept is another word for root, 0, solution, which is also your answer. All right. Explain those answers for x equals negative 2.5 and negative 5 halves. This is easy but essential. So when you put this in decimals, you get 2.5. 2.5 is 5 over 2. Well, since this is negative 2.5, it's going to be negative 5 halves. This is very essential to know because on your ACT, you're going to be in a situation where you have to convert decimals into fractions on the fly. I'm going to show you how to do that so you get your ACT scores to increase. All right. Put this in decimals right quick. Try it out. I'm not going to comment on this video. Comment on this remark. I just want you to just try it. Pause the video and just try it. Oh, that is going to be a problem, isn't it? So before you do this in decimals, anytime you see a variable like x, n, t, x, anything like that, put your variable as x. 16x squared minus 9. I'm doing this by a keypad, y'all, so I'm sorry about writing like this. I don't have my marker on me, or else I would have just written out for you. So turn n into x. Turn x into x. Turn n into x. And try it out. When you try, you should have a graph that looks like this. And when you graph it and zoom in enough, your x-intercept should be these two values, negative 3/4 and positive 3/4. Negative 3/4 and positive 3/4. Okay. X-intercept is another word for 0, roots, and solution. X-intercept is another word for roots, 0, solution. Alright, moving on. Alright, so we have did our little work so far. So I need for you guys to use lesson 11 and follow my directions verbatim. Factor each of the trinomials using the correct methods. Then you're going to solve the equations by hand. Then you're going to verify it by graphing. After I review the work, I want you to try out exercise 1. Alright, so you guys, this is the problem for the Eureka lesson. So, for my friends who are at home, I want you guys to try this out using those trinomial methods. If you don't remember, please look at your notes. If you don't remember, please look at previous videos. And let's see. Alright, welcome back. Did you factor the equation to the left? Did you come up with those answers? Did you take those answers? Did you set those answers to 0? Did you solve for x? Did you verify this using decimals, being your x-intercept at -3, -2? All right. Ooh. Did you do the right one? Did you get those numbers? Did you factor those? Did you get that? Now, your numbers are switched, that's fine, but listen up. When you take your ACT, when you write your solution, it's going to be the smallest to the large. On your quiz, I may make this a little challenging by telling you put the small number in front first, then the large number in the back when you telling me your solutions. Because again, when you take ACT, they're going to put in that format. So be careful. Alright. And the graph right here, what you see is me putting in decimals. And my answers for the equation to the left and for the equation to the right both match. So you used to zoom in when you put this decimals, you're going to get these be your x-intercepts for each graph. How you doing? You doing alright? So far so good. This is stuff that we've been talking about, but I can't, you have to by now be able to know how to do all of this. So please don't come next class period not knowing this, because otherwise you're going to be in trouble. Now, you're going to have a unique case of factoring a trinomial. You'll have a trinomial that looks like this. By now, you guys should be familiar with the swing method. I have taught it to you. I have put in a lot of problems, put on your last quiz. Y'all sure already know how to make short work of this. So, I'm not going to tell you what to do verbatim. Well, I'm not going to tell you what to do, period. I need for you to try this problem on your own and pause it. Pause the video and try it right now. Welcome back. So, hopefully, you multiply A times C and you rewrote. And again, if you are lost by that, please go back to my factoring video. Alright? Go back. In math, you have to constantly practice and review through your material. If you don't know how I got to this step, please review. All I did is multiply 4 times 1, which was 4, and I rewrote. From there, I just found my numbers. You know how we do with this. And then I do what else? Divided by 4. But here's something that's going to be important for us to know. These factors repeat. They repeat each other. They're the same thing. So when that happens, you will have a multiplicity. So that means that you're going to have a multiplicity of 4x minus 2 square. When you have that, that means these factors repeat twice. These factors repeat twice, and because they repeat twice, you could rewrite it with the exponent too, which is called your multiplicity. So that means because they repeat, I only have to solve the equation once. So because you will solve the equation only one time, you're just gonna treat it like a regular equation and solve for x. Add 2 to both sides, and when you add 2 to both sides and divide by 4, you realize that it's going to simplify to 1/2. And when you do that, because you have one solution, it's not going to cross the x-axis, it's just going to touch. It's only going to touch the x-axis. So remember the question I asked you earlier? Do the leading exponent? I always tell you the number of solutions you have. Not always. Sometimes you could have a multiplicity of 2. And when that happens, that means your solution is just going to be a one repeating solution. So if that happens, that's that. All right. And going on to multiplicity, when you have factors repeat, like this right here, you're going to have a 0, which is 1/2, which that's what we did, and a multiplicity of 2. All right. So this is an example which I want you to try. Well, you don't need to try. I'm just going to tell you because this is a new concept. So x minus 5 squared, because it has a multiplicity of 2, all that I have to do is just do the equation once. X plus 5 has a multiplicity of 2. Solve it like an equation, be about my business. And x plus 2 don't even have a multiplicity. It's just x plus 2. So you're going to solve all these equations here just once. So x minus 5 equals 0. When you solve that equation, which you should know what to do, you know you're going to get 5. You're going to get 5 with a multiplicity of 2, negative 5 for this one with a multiplicity of 2 over here, and then this is going to be negative 2. And that's it, y'all. Nothing to it. It's just like that. And again, by this part, you should already know how to solve equations. If you do not know, please go back to the previous videos. Because in these videos, because by now you should know how to solve. We're going to move on. So sometimes you're going to have a situation like this where it's not even factorable. So you can't factor it. You can't solve it by factoring. So you're going to have to solve it by using your quadratic formula. So the formula is like this. Well, let me drink a little water because I'm about to sing for you. Sing my little voice. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Yes, I know. I'm a great singer. Because I made it Broadway. Anyway, moving on. So I sang it to you. Now, you gotta put stuff in place. So, like we did in the past, let's label it. So before I continue, please be mindful and know that when you see x by itself, it will always have a coefficient of 1. It's always going to have a coefficient 1. X always have a coefficient of 1. X always have a coefficient of 1. X always have a coefficient of 1. So once you understand that, you can label A is 1, B is -4, C is 24. Right? So now you just have to put the numbers in the formula. See what happens? I just plug in all the numbers. And that's what you're supposed to do. So these two negatives going to be rewritten as a positive, right? And we know that a negative to an even power is going to be positive. So you're going to have +4 plus or minus 16 minus 96 over 2. When you do that, you're going to have -80. Now, the one thing that I'm going to do, just so you guys could understand a little bit more, is to rewrite -80 until you get a perfect square. -16 times 5 gives you -80. Now we know for a fact, can we have a negative number in the square root? No, you can never have a negative number in the square root. But we know 16 is the perfect square of 2. So that -16 you're going to pull out is going to be 4i. The 5 is going to stay inside the square root. It's going to be 4 plus 4i square root of 5 over 2. Now, before I talk about the final answer, just know that you could simplify all this. You can simplify these 4's and these 2. They all have a 2 in common. So that's why we are left with the answer, because I cancel out. Because 4 going to 2 two times, 4i goes into 2 two times. So that's why it's going to be minus and plus. Don't forget your solution is twice. It's going to be a plus and a minus. Plus and minus. I, remember what I told you about the ACT? The ACT going to go for x equals your small over your large. That's it. That's all you gotta do, y'all. And again, that's just a quadratic formula. If you need details, I will supply a video that gives you all the details of the quadratic formula, okay? So again, if you need help with that, I will have a video with the details of the quadratic formula. Alright, so before we continue, I need to remind you guys about these graphs and what the images could tell you. So, we have worked in a situation where we got one solution. And when we have that one solution dealing with polynomials, that just means that when we solve our equation, that means that we just had something that was 0 in the square root. When that happens, you won't have an x-intercept, but it's going to touch your x-axis. It's going to touch it, but it won't be an intercept of it when you're dealing with polynomials. So when, for example, this equation, when you solve it and you do all that, you'll get 0, and it's going to look something like this graph. It's going to be skinnier, but it's going to look very similar to this graph. It's going to touch the x-axis, but it's not going to cross through it. So therefore, it's going to be one real solution, or it could be a situation with possible multiplicities. So when you have something like 4x minus 2, and if it's squared, when you solve this equation the inside, that's just going to tell you where the where the graph going to touch. It's going to touch at wherever that value is going to be when you solve it. So it's not going to touch 0, it just means you're going to have one solution. So those are those examples. So again, is when the square root is 0, or when you have multiplicities. And usually with like a multiplicity of 2 in particular. Again, a multiplicity of 2 produces this graph. Keep that in mind, y'all. Here, you have a graph with 2 intercepts or solutions. When that happens, that means that the square root, the number inside the square root, is positive. And when it's positive, that means you're going to have 2 solutions, or you're going to have more than a plenty of multiplicities. So maybe you have a multiplicity of 3. So long story short, if your multiplicities is 2, if it's greater than 2, if your multiplicities are greater than 2, they may look like this, but in most cases it's just the square root is positive, or your multiplicity is just greater than 2. For example, this equation, this particular, well, quadratic is going to be a little bit different because when you solve these two, you have two distinct answers. And of course, you didn't need to take the square root of both sides. And of course, you don't have a multiplicity of, there's nothing to repeat, so it's not multiplicity. So in this case, when you are factoring a trinomial with two different factors, that's also going to be a result as well. So you got three things to look at. Is it positive in the square root when you take the square root? If you can't factor, if it's not factorable, of course. Or is it a multiplicity greater than 2? Or is it a trinomial that you could factor that gives you two different factors? So three things to keep in mind. Again, if I'm going too fast, review all of this, okay? So here, you have a situation where the graph does not touch. That just means that if you have to take the square root, that means you have a negative number in that square root. And when that happens, of course, you're not allowed to have that. It becomes imaginary. So because it's imaginary, it never touches the x-axis. 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 Alright. So, however, you don't have multiplicities when it's imaginary. I highly doubt that you're going to come across a multiplicity that has some imaginary factors, like this problem, for example. If we take the square root, because it's a negative number, it's not real, and you just do that. Alright, so yeah, go ahead, try your Eureka lessons, try these problems out, alright?